for most of this class, we're working with ordinary least squares regression, or OLS regression. And what that means is that the best fitting line is calculated by minimizing the sum of the squared distances from the actual data points to the line. So in other words, we're minimizing the residuals. So if you look at this graphic, all those red double-headed arrows indicate residuals. So residuals mean the distance between the actual observed values and the best fitting line. Remember, if we had a perfect correlation, all of our data points, observed data points, would be along perfectly along that that best fitting line. But since they're not, and typically they're way off the line in real world research, right? There's a lot of error usually, and so that's totally normal, and we have residuals, but we just want to predict better than the mean. So remember, we want to do better than our best guess of the mean of y for any given level of a predictor. Okay, so the reason that it's the sum of the squared distances is because if we just took the distances themselves, they would equal 0. Remember, all the residuals sum to 0, so we need to square them first, similar to the way we square the deviations when we're calculating variance and standard deviation. So it's the same kind of idea. Okay, so the arrows represent the observed y minus the predicted y values, and these are residuals. And if the correlation was 1, we would have those points they would all be on the line perfectly.